folks, welcome back to my YouTube channel Code to Create. In today's video, we're going to see how to create a model that predicts if your loan is going to be approved in bank or not. So let's get started. I have already created a new Python 3 file in Jupyter Notebook. First, we have to begin with importing the necessary libraries. So let's do that. I'm going to import numpy as np. I'm going to import pandas as pd. I'm going to import cbound. This is necessary too for the plots. I'm going to import cbound for the plots. I'm going to import matplotlib again for the plots. I'm going to say from matplotlib import pyplot as plt. And then I'm going to import zscore for the outlier stuff. So I'm going to say from skyp.stats import zscore. And then I'm going to import simple imputer. So I'm going to say from sklearn.impute import simple imputer. Oh, sorry guys. Simple imputer. And then I'm going to import label encoder. I'm going to say from sklearn.preprocessing import label encoder. And then I'm going to import power transformer. So I'm going to say from sklearn.preprocessing again. Preprocessing import power transformer. And then I'm going to import min-max scaler. So I'm going to say from sklearn.preprocessing again. Import min-max scaler. And then I'm going to import train test split. So I'm going to say from sklearn.model selection import train. Oh, sorry guys. Train test split. And then I'm going to import logistic regression algorithm. So I'm going to say from sklearn.linear model import logistic regression. And then let's import k-neighbors classifier. So I'm going to say from sklearn.neighbors import k-neighbors classifier. And then let's import svc support vector machine. So I'm going to say from sklearn.svm import svc. And then let's import random forest classifier. So I'm going to say from sklearn.ensemble import random forest classifier. And let's also import AdaBoost classifier, bagging classifier, and gradient boosting classifier. This is all from sklearn.ensemble. So let's just put a comma and then do it. So I'm going to say AdaBoost classifier, bagging classifier. Bagging classifier is also an algorithm. Don't worry guys, I'll be making a video about bagging classifier very soon. And then let's import gradient boosting classifier. And then let's import decision tree classifier. So I'm going to say from sklearn.tree import decision tree classifier. And then let's import Gaussian naive Bayes. So I'm going to say from sklearn.naive _Bayes import Gaussian naive Bayes. And then let's import grid search CV. So I'm going to say from sklearn.model selection import grid search CV. And then let's import all the metrics. So I'm going to say from sklearn.metrics import accuracy score, classification metrics, confusion metrics. Confusion metrics, F1 score, average precision, average average precision score, adjusted mutual info score, balanced accuracy, core, raw curve, and AUC. Okay, it shows an error. Where? Oh, sorry guys. Yes. Where does it? Okay, when we import matplotlib, it shows the error. Okay. Let's run this. Another error. Okay, guys. Yes. By the time it imports, let's. Oh. Oh, guys. Matplotlib. Yes. Now let's read our another one. Okay, naive base. Okay, wrong spelling again. Another one. Cannot import name classification matrix. Okay, classification matrix. Oh, okay guys, this is actually classification report. I'm very sorry. Let's run this up now. This should work. Yes. Now let's read our data set, guys. So I'm going to say df is equal to pd dot read underscore csv. Yes. Let me run this, guys, and I'm going to say df. Yes, as you can see, we have the loan ID that will be removing soon. And then we have gender, we have they're married or not, we have the number of dependents they have, their education, if they're self-employed or not, their application income, their co-application income, loan amount, in loan amount term, their credit history, their property area, if it's urban, semi-urban or rural, and their loan status, if it's approved or not, basically a target variable. Let's check if we have any null values here, and let's check how many null values we have. So I'm going to say df.isNull.sum. Yes, okay. In gender we have 13, in married we have 3, in dependents we have 15, in self-employed we have 32, and we have loan amount 22, loan amount term 14, credit history 50. Let's first know the description about it. So I'm going to say df.describe. We'll basically know the count, mean and all. So in this, when we put df.describe, in this description, we'll find about the count, mean, their 50%, their 75%, maximum, minimum, all those things. So first let's check the value counts in gender. So I'm going to say df of gender so we can fill the null values. Dot value counts. We have male 489 and female 112. And using simple imputer input, let's clear all these null values in gender using the most frequent value. So I'm going to say imputer is equal to simple imputer strategy is equal to, we are using the most frequent, so I'm going to say most frequent df of gender is equal to imputer dot fit transform form. What we're gonna do, we're gonna fit transform the gender from df. So I'm gonna say fit transform df of gender dot values. Let's reshape this to -1 and 1. So I'm gonna say reshape this. I'm gonna reshape this to -1 and 1. Let's run this up. Okay, we have a small error. Oh, yes, guys. Now it should. Yes, it worked. Let's check our gender column now. Yes, let's check if we have any null values here. Yes, we have 0 null values. And we're gonna do the same thing for the married column as it only have 3 null values. So I'm gonna copy this up. Let's paste it up here. And let's put the column married. Yes, there are more number of married people than unmarried people. So it's 398 married people and 213 unmarried people. Yeah. And now let's check if we have any null values in our column. Married dot is null dot sum. Yes, we have 0 null values in married 2 now. And next, let's check where we have the null values. We have it in dependents, that is we have 15 null values. Okay, okay guys, so let's do the same for everything right now. Let's do the same for everything. So I'm gonna do that. Let's just copy this up and let's paste it. From we basically have it in dependents, we have in self-employed, we have it in loan amount term, we have it in loan amount and credit history. So basically 5. Yes, and now let's fill the columns up here. We have self-employed next. Self-employed. Self-employed. And let's do that for loan amount term. Loan amount term. Loan amount term. And then the credit history. Credit history. And we have the loan amount. Okay, it's like this. Yes, guys. And now let's check if our data frame have any null values. So I'm going to say df dot is null dot sum. Okay, if we have it in the dependents, and that's totally fine guys, because I didn't clear any null values of dependents column here, and I'll see you guys why later. And now what we're going to check is in dependents column how many people are married and how many people are not married. So I'm going to say df of dependents dot is null. Check how many people are married dot value counts. Okay, there shouldn't be any error. Okay, yes guys, now it should work. Yes, in our in dependence null values, number of married people are 11 and number of not married people are 4. And let's check how many unmarried people are having 0 dependents, 1 dependent, 2 dependents and 3 plus dependents. So we're gonna do that by saying df of married is equal to no dependents dot value count dot value counts. We have 23 unmarried people who are dependent on one thing, and we have 8 unmarried people who are dependent on 2 things, and we have 7 unmarried, and we have 7 unmarried people who are dependent on 3 plus things. So as we can see, most of them are yes in this dependence. So I'm going to say df of married is equal to, we are basically clearing the null values here. So I'm going to say df of married is equal to df of married dot replace np dot nan, that np dot nan, that means null values, to yes. And in dependence, let's replace it to none. Let's just replace it to none. Let's say null, that's all. So I'm going to say np dot nan, comma, let's replace it to the word none. I'll tell you guys why. And now we need a function. So I'm going to say, I'm naming this function as fill depth, that's fill department null values. And the columns we need is married and dependence. So I'm going to say if dependence is equal to null, then let's put this if dependence is equal to null and if married is equal to no, then let's return 0. That means let's just say it's 0. They have 0 dependence. Else, let's return dependence, and else return dependence. There should be no errors. Yes, like I said, no errors over here. And now let's apply the lambda function. So I'm going to say df of dependence is equal to df dot apply lambda and x is equal to fill this null values, the function, and the columns are married and dependence. Let's set the axis to let's set the axis to 1. Okay guys, I guess we've done a small mistake. I feel that we've done a small mistake over here. Apply lambda. Oh yes guys, let's do this. What we have to do is yes, now it's correct. Let's put a comma up here. Yes guys, now it's clear. Let's set the axis to 1. Let's run this, and then let's just replace null with 0. So I'm going to say df of dependence is equal to df of dependence dot replace null with 0. Let's run this. Yes. Next, let's drop off this loan ID as it's not needed in our model. So I'm going to say df is equal to df dot drop loan ID, and let's set the axis to 1. Yes. And now let's encode gender. So I'm going to say let's use label encoder for this. I'm going to say L is equal to label encoder, and then I'm going to say df of gender is equal to le dot fit transform. So here basically fit transform is used for transforming this gender column into zeros and ones. Sorry guys, df of gender. Yes. And let's do the same thing to married, as married also have yes or no. So I'm gonna say df of married, df of married. Yes guys, and now it's time for checking our skewness. So I'm going to say df.skew. Okay, we have a bit of skewness, and yes guys, we have a bit of skewness. So I'm going to say, let's use power transformer now. I'm going to say pt is equal to power transformer. Yes, and over here if we see guys, df of dependence, we have like 3 plus over here, so we have to convert this to 3. Let's do that. I'm going to say df of dependence dot rename index is equal to 3 plus 2, 3, and let's set the in place to true, as we don't want it in our, like, we don't want this 3 plus in our data set. Yes guys, now if we check our dependence, oh, we again have 3 plus. I don't know why this is happening. Yes, for now let's just leave it up like this. And now it's time for the visualization. I'm not going to do much of visualization over here. I'm going to use only one plot, and that is we need the heat map, the correlation with heat map. So I'm going to say plt dot figure size is going to be 1510, and let's say sns dot heat map df dot correlation comma and not is equal to true, as we need it to like show the sidebar which says which is the highest and which is the lowest. So I'm going to say and not is equal to true, and c map, the type of map, is equal to POP. Yes guys, we can see I was showing about this one for the annotation up here. Yes guys, now it's time for the outliers. So I'm going to say z-score. As I said in the beginning, we're going to use z-score for all this outlier stuff. So I'm going to say z-score is equal to np dot abs z-score of df. Okay, it shows an error. Z-score is equal to np dot abs of z-score. I don't know why it shows the error guys. Yes guys, and then we have to use the min max scaler, and we have to also, yes guys, and then let's just create a class, let's just create a class for min max scaler. So I'm going to say scale is equal to min max scaler, and let me set the x and y too. I'm going to say x is equal to df dot drop loan status, and let's set the axis. So I'm going to say axis equals 1, and let's set the y to df of loan status, and then let's say x is equal to scale dot fit transform from x. It shows an error guys. Okay, I don't know why it shows this error. I've tried renaming it too. This shouldn't be showing an error. Let's try. Wait, let's put a comma. No, it shows an error if you put a comma. Oh, okay. I guess we have missed a few. Okay. I guess we have missed a few steps, guys, and one of them is converting our columns, our categorical columns, to zeros and ones. Let's do that. So I'm going to create a variable categorical column. So here I'm going to put all my categorical columns. I'm going to say gender, married, dependence, education, education, self-employed, employed, property area, and loan status. And then let's use label encoder to create, and then let's use label encoder to encode them. So I'm going to say L is equal to label encoder. I'm just creating a class over here, guys. Say for column, in categorical column, let fit transform each and every column. So I'm going to say df of col is equal to le dot fit transform df of column. Oh, where is the error? Where's the error? Yes, guys, it's completed. And now we have to check the outlier. So I'm going to say z score, just like I said in the beginning, guys. Z score is for the outlier things. I'm going to say z score is equal to nb.abs z score of df. Yes, we have cleared all our outliers if any outliers are there. And then let's do this step. Let's run. Yes, guys, like I said, no null values. And then we have to create another function, guys, that is the model select. So I'm going to say def model select of model max score is equal to 0, max state is equal to 0. I'll tell you why these variables, guys. For x in range 42 to 105, let's use this range in x from x. So let's split our data set now. I'm going to say x train, x test. Use this order, guys, or it's going to show an error. Y train, y test is equal to train test. Oh, sorry, guys. Train test split x and y, and the test size to 0.3, and let's set the random state to x. And then I'm going to say md is equal to model. So every time we use md, it comes as a model. I'm going to say md dot fit x train comma y train. And then let's say predict is equal to md dot predict x test. Okay, guys, so how this works over here is that we're going to fit the model. Also, we're going to train our model using x train and y train. We're going to say this is this, this is that, and then we're going to predict our x test, and then we're going to say in model dot predict x test, we're going to say predict x test, because we're going to use all these columns to predict our y, that's our target variable or loan status. I'm going to say FPR TPR thresholds is equal to raw curve y test comma predict. I'm going to say a curve is equal to a, oh sorry guys, is equal to AUC of F. Oh god, FPR and TPR. And then let's get our accuracy score. So I'm going to say ACC is equal to accuracy score of y test and predict. I'm gonna create a if condition now. So I'm gonna say if accuracy score is greater than our max score, then let's set our max score to our accuracy score. Max 8 to x. And now let's print our max score. Max score is with random state and then I'm going to say dot format max score comma max state. Yes guys, and now let's just say model underscore select. We're calling the function logistic regression, the algorithm. Oh. And the max iteration to 4000. Let's copy and do the same for the others. I'm gonna do the same for k neighbors classifier. So I'm gonna say k neighbors classifier, and we don't need any max iterations over here. Let's run this. Let's do the same for SVC. Let's do the same for all our algorithms, all our other algorithms too. Run this. Control V, model select. Let's do the same for decision tree classifier. Okay guys, we don't need these max iterations anymore for other algorithms, so I'm just gonna do this. Yes, let's do the same for our random forest classifier. Our Adabos classifier. And then our Gaussian ABS. Let's wait till it runs, guys. Yes. Gaussian ABS. Our bagging classifier. Our gradient boosting classifier. And let's check which one gave us the best accuracy score, which one is our best for this model. 83, 82, 85, 83, 82, 75, 85, 84. Okay. One or two, random state 102, 63. Okay, so we have 85 from our Gaussian base, and we have it from SVC and logistic regression. Let's check the third number, 9. Again 9, and then 4, 5, 9. Okay, let's take a random state, 63, 63. Okay. Okay, out of SVC and logistic regression, let's just use logistic regression. Yes guys, let's just use logistic regression. So I'm gonna say x train, x test, comma y train, y test is equal to train test split. I'm splitting it up. We've just splitted it in our model, not outside. So I'm going to say not outside our model. So I'm going to say train test split x train y x test y train y test is equal to train test split of x and y. X and y. The test size again to 0.3 and our best random state, that's 64. State to 64. And model is equal to logistic regression, max iteration to 4000, lib linear. And then let's fit this up. So I'm going to say model dot fit x train comma y train, and then I'm going to say predict is equal to model dot predict x test. Let's run this up, guys. Train test, okay, sorry guys. Train test split x is not defined. I guess it's the higher case one. Okay, another error. Yes, guys. And now let's check our confusion matrix. Let's print our confusion matrix. So I'm going to say print confusion matrix of y test and predict our actual value and our predicted value. I'm just going to leave space and again print classification report of y test and predict. And now we have to do our final yes guys, and now we have to do our final step, that is dumping our model. So I'm going to say joblib.dump model and let's save this as load status model. Joblib, okay, let's just import it up. Import joblib. Yes guys, now we know how to create a model that predicts our loan status. Thank you friends. Please do like, share, subscribe and comment below. Bye bye.